Hi there, welcome back. Here we have something rather unique. I have a strange bunch of friends, pretty fanatical about their hi-fi, so I'm quite fortunate that I get the opportunity to mess around with some of these unique pieces of equipment. And this one really fits the bill. This is a preamp. That's all it is, a preamp. It's a Korato 10th anniversary reference valve preamplifier. That's what that top section is. And then below we have a valve power supply. And in fact, we have two. So what this is a dual mono preamplifier with separate power supplies, valve driven. And I must confess I've opened one of the power supplies already, so I can actually affirm that this is probably the biggest case of overkill I've ever seen, and you'll understand why when I go into the details. What I'm going to do here is I'm going to keep a log of this attempted repair, because what this thing has got is a problem with some crackling noises that come up sporadically, and I believe it's probably one of the valves, but we'll find out. So what I'm going to do is actually at least the power supply, go through it and get a schematic for it, draw it up, reverse engineer it, and see where the problem of the crackling may be. And hopefully this will be interesting to some of you who have never seen the inside of one of these things, or who have one that you're trying to repair and you can't figure out how the schematic fits together. So yeah, let's delve a bit further and see what we find. When we look at the single supply, and I mean single supply, it's really supplying just one of the channels. The two are identical. This is all we have on the front. Korato valve power supply. I've never seen one of these before. This is a first. And all it has is a switch on the front here. It's got a mains power connector at the back, and then it's got this umbilical cord coming out with a 5-pin. This is one of those sort of microphone sockets that they're very good because you actually screw them on, and it means that they don't come loose. So it is pretty good for supplying power. Not lots of power, but then again, as you'll see, this thing doesn't really supply much current anyway. From what I've been able to determine, the maximum current capacity of this box is about 30 to 35 milliamps, which this is the start of the overkill description that I gave to start off with. 35 milliamps from this thing. Now, you've got to admit, it's a beauty. I mean, brushed aluminium, it's really, really nice when you look at it from the outside. What you'll find when you open the top is a little bit surprising, but you'll figure it out for yourself. And here we have it. This transformer is pretty big. Toroidal, obviously, has to be, for the quietest supply possible. It's got a massive choke over there. That's what that thing is. It's got the power connector at the back. The umbilical cord going out at the back as well. The sides are in wood, and it really does look sort of hand-built and handmade, and I'm talking about the chassis at the moment, because the rest is definitely handmade. If you look at the way they've wired this together, you've got a power resistor that's sort of hanging in the air there. And when I go through and work out the schematic, we'll see what that resistor is doing. Various bridge rectifiers down there. It's actually 3 capacitors. And then we've got 2 tubes. And these tubes are quite interesting because I had never seen this thing used as a voltage regulator. And this is an ECL82, which is it's a triode and a pentode in one. Now these things I've seen before, this particular valve or tube, because they used quite a bit in German tube radios, which I've done quite a few restorations of. And the reason these things are popular, or were popular, is because you get a preamp and a power amp in one envelope, in one tube. You can use the triode as a preamp, audio preamp, and then the pentode section drives the output transformer as your power amplifier. So it works pretty well. So that's now being used as a voltage regulator. And it took me a while to figure out what this was, because as I said, I'd never seen a valve or tube voltage regulator before. This thing is a 85A2, and it's an 85 volt, 85 volt reference tube. So this thing is the precursor to the Zener diode. That's really all it is, and I've looked it up, and that's really what it does. You put a current through it and it gives you a steady voltage. It takes quite a while to warm up and to achieve its voltage, so it has a slow turn on, which is an advantage. But that's really all it is. And the one thing you'll find here that's pretty interesting is that this is actually a DIY board. This is self-etched, home-etched. And I took this out to work out the circuit, but I put it back to test for voltages, and there's not really much to see except some pretty shoddy soldering. And this is what I find quite amusing. These things are incredibly expensive and sought after, and the quality is, well, the quality of the results probably good, but the quality of the work is pretty amateur, which I find quite ironic. If you look at those guys down there, you see the two linear voltage regulators and the way that they've actually wired everything in. It's a little bit, how you doing, you know? Yeah. Well, it works, so I guess that's all you need. And what we get out of here is various voltages that come out on that plug there. One of them is a B+, regulated B+. Obviously for the tubes on the preamp section itself, as I said, on one channel of the preamp section. The other is a heater voltage, 6 volts, not 6.3. And the other is also a heater voltage, but referenced to a higher voltage. In other words, it's not 6 volts referenced to 0, it's 6 volt referenced to 70 something, I think it is. But anyway, this is it for now, and the reason I've closed it all up is I wanted to test for voltages and put the outputs on a scope and see if the problem was not one of the tubes. I haven't worked that out definitively yet. The way I'm going to do that is swap tubes from the left to the right channel, and hopefully we'll get an answer. The capacitor's all fine. I've measured them, tested them. The ESR is low. Those stubby ones are Nishikons. Very good quality actually. So there's not much to go wrong there. And let's have a look at what the schematic tells us. Here's the actual full schematic of the power supply section. I've drawn it all in one, a little bit like the old tube radios, the German tube radio schematics where everything is one page. I quite like that. Get to see everything that's going on. And as far as I can determine, this is accurate. And then the logic of how the schematic works also makes sense. Now, this is not the first version that I came up with. Obviously, when you're drawing a schematic, you just sort of wire things in as you see them, and then the result is transferred to something neater to make it more visible. But this literally has 4 outputs from that transformer, and we'll go through each one and I'll tell you exactly what they do and how it works. So here's our first section. We've got the live and neutral coming in. The earth from the mains earth is not connected to anything. In fact, the mains earth tag on the IC connector is cut off. So this thing isn't earth referenced or mains earth referenced at all. Obviously, when you use it as a preamp, one of the pieces of equipment or more will have some kind of earth reference, and the reason they do this is to avoid ground loops with this piece of equipment. Now, 230 comes in, there's a switch, that's that front switch in the front there. There's a LED inside, we'll see how that's powered next, and it goes into the primary. The first winding that comes out is this one here. It has a 2.4 ohm 10 watt resistor. That's that white ceramic resistor that you see there hanging in the air. A little bit loose, but it does the job. 4 diodes, bridge rectifier, full wave rectification. Goes through a 4700 microfarad capacitor, 25 volts. It then also leads off from there to power the LED on the front through a 2K resistor and LED that's in the front panel. It then goes into one of those linear voltage regulators, the 7806, producing 6 volts regulated out, referenced to 0 volts. Okay, that's a thin black wire that goes into the cord that comes out the back, and that's a thick black wire which is your ground, really. Okay, that's the first one. We'll get these two out of the way first. Another one of the windings just comes out producing 6.3 volts or so, and that goes to pin 4 and 5 of the ECL82 within the power supply itself. That's just heater voltage for that one tube. There's only one tube that needs heater voltage inside this power supply, and that's produced by a separate winding. Yep, it could have been done from there, but they don't want to mix the functions so that you get as clean a heater supply going to the preamp as possible, and they seem to have achieved that. The other winding, this one down here, that's producing a 6 volts as well. You have another bridge rectifier, 2200 microfarads is 16 volts. You've got 7806 as well, same as the top one. That's the second linear voltage regulator you see there. And then you have a yellow wire and a white wire going off through the umbilical cord. And then there's a difference here. You have 2 resistors, 330 ohms, producing a midpoint here. Now remember, this thing isn't referenced to ground at all at this point, okay? It's floating. There's 6 volts floating somewhere. And now they're going to reference it. And the way they do that is they link that to a voltage divider over here, coming from the regulated supply, which is from the top section there, which, for your information, happens to be, I measured it, 221 volts. So they put 221 volts in there, and then you have a 130k resistor and a 270k resistor, and this forms a divider, okay? About 1/3, yeah, 1/3 of the voltage. So the voltage there is about 70. Now, the voltage there is added to that point. So that point there is at 70 something volts, okay? Call it 72 volts. And then the difference between those two is 6 volts. So that's +3 -3. So +3 volts, that voltage, +3 volts, that voltage, -3 volts over there. Okay. And we'll see that when I measure the pins, I'll show you what voltages I got there. This one is stabilized with about 100 microfarad capacitor, referenced to ground. Now that becomes a reference voltage. It's raised for the purposes of one of the heaters inside the preamp. And my guess is it's a cathode follower, where you want to keep the heater voltage pretty close to the cathode voltage, so you don't get any noise and any damage coming in there. That's why you have a separate heater voltage for that. Okay, now this thing is fed by the regulated B+, which we'll see next. And here is the regulated supply. You have the secondary feeding a bridge rectifier, no mystery there. Goes through a 47 microfarad or into a 47 microfarad filter cap at 385 volts. It then goes through that choke that you saw there to reduce the ripple further and meets another 47 microfarad capacitor. So this is your filtering. You then have a B plus over here, unregulated B plus. That's where that would be. So forget about this for now. That's reference to ground. You've got B plus coming in there, unregulated. And then we have this, the part that I find rather interesting. It's using the ECL82 where it has a pentode and a triode as a regulator element. And the way this works is the ECL82 pentode is wired in triode mode with a 470 ohm resistor to the screen grid. So it doesn't have a separate supply. It's really from the main anode supply, which can be pretty high because the ECL82 can hold up to, I think it's 900 volts. Okay, that then acts as a pass element to provide the regulated supply, the B plus regulated, okay, which happens to be the red wire that goes into the umbilical cord. Now, one thing to bear in mind though is the maximum current you can get there rated on a spec sheet for the ECL82 anode current is 35 milliamps. So this whole thing is producing a very, very low current. But that's all you need for a preamp. So I guess it does the job. Hey. Anyway, then they use the triode section of the ECL82 as effectively an error amplifier. And the way this works is there's an error on this schematic. I've just figured it out. Yep, there's an error in the schematic. And I'll tell you what that is. This voltage divider does not go to there. That one goes to there. That voltage divider is in the wrong place. That's better. Okay. Wasn't making sense for a second there. So we have the anode of the triode pulling the grid or acting on the grid of the pentode. That's the grid 1 of the pentode through that 10K resistor. It is being fed from the regulated output by a 270K resistor to its anode. Okay. And the voltage that it's seeing on the grid of the triode is that combination, 150 kilo ohms, 150K, 270K, produces a voltage divider here again, which feeds the grid. Now, you'll find circuits like this on the web. In fact, if you look for a single ECL82 tube voltage regulator, you'll find this exact circuit, practically exactly the same, with the difference they use a Zener diode over here. In this case, they use a reference tube, 85 volt reference tube, but you could just as easily put a Zener diode, an 85 volt Zener diode, they would work just fine. So what they do here is you produce a sampling of the output voltage. That's that sampling, the ratio of 150 over 420 times 221, okay, goes into the grid. And that regulates, because it's got a reference, this cathode of the triode is raised by 85 volts or so. In this particular case, it's actually 82 volts. I measured that. The output is then forced, this acts as an error amplifier and keeps correcting the output current here that it's drawing and voltage to make this voltage here remain as stable as possible. Now, there's one more thing here. Two more things actually. This 34K resistor, this could very well have been from the unregulated B+, but they use it from the regulated output to feed the Zener, the voltage regulator IC tube. Quite a difference, eh? So you're basically taking 220 volts, feeding it to the anode of the regulated tube, producing 220 minus 82 divided by 34 is about 4 milliamps of current, which is enough to keep this thing stable at the reference voltage. Smoothing there with 0.1 microfarad capacitor just to get rid of some noise that you might have produced over there. So that basically biases the regulator tube. That regulator tube produces that voltage at the cathode of that triode, and the cathode of the triode takes that voltage there, which is a ratio, a proportion of the output voltage, and makes sure that it stays constant by acting as an error amplifier between the voltage that's coming in there and the voltage it's sensing over there. Okay, so far so good. So what we have then is one more component over here. What this does is it actually allows any ripple that's still on that regulated line to go through in its entirety, because the voltage at the grid of this triode is a proportion, that ratio, of the output voltage. It also sees the same proportion of the ripple if that capacitor is not there. What they've done here is they've made it a low impedance path for ripple so that the error amplifier sees all the ripple, corrects for all the ripple, and in theory gets that ripple down to 0, while the DC voltage, 220 volts, I presume that's what they were aiming for, is seen in the ratio that those resistors provide. So it works very well. It actually works very, very well. My opinion is that it's a hell of a bit of overkill, but if you're going to do something old style, and this is not from the tube era, this I think is from the 90s, so if you're going to do something old school, then I suppose this is the way to do it. I'm surprised it didn't use valve rectifier. They could have done that and kept it really old school, but no need. I suppose they decided that would have been just a little bit too much on the overkill section. So yeah, this is how that part works, and the result is 221 volts. Now, when we look at the plug that comes out, that goes into the preamp, looking at it, this is the pinouts we have there, and this is what we have. We've got the thick black wire, goes to that pin 1, 0 volts. The thin black wire is the 6 volts referenced to 0, to ground, 6 volts. Not 6.3 or anything like that. They've actually made it lower than what the tubes will probably, should probably work with at 6.3, but that's fine. So regulated 6 volt heater voltage. The red wire is the B plus regulated, which I measured at 221 volts. So that's there. The yellow wire and the white wire, if you recall, are those two that are a heater voltage raised, and it's raised to about 71, 72 volts by that other potential divider we have there. And what it does is it gives you, between that point, white and yellow, you get 6 volts, but it's referenced to 71. So 71 plus 3 gives you 74, 71 minus 3 gives you 68. That's what that's doing there. That's a heater voltage for another set of tubes or another tube, as I said, probably acting as a cathode follower. So you create as small a difference between the heater voltage and the cathode as possible. And that's really all there is. I'll show you the actual pinouts of the tubes. And here it is, the ECL82, the pentode. Pin 3 is the grid, 6 is the anode, 7 is the screen grid, 2 is the cathode. The triode section of that same tube is grid 1, grid is pin 1, anode is pin 9, and the cathode is pin 8. And then you've got pin 4 and 5 is your heater voltages produced by that one winding. Okay, then the voltage regulator tube is the 85A2. The cathode has 2 connections, pin 1 and 5, and the anode is pin 1 and 5, and the cathode is pin 7 and 2. This particular one is an 85 volt reference tube. The rating, I believe, is from anything from 1 milliamps to 10 milliamps. We've got about 4 or 5 running through it at the moment, so it works pretty well. My guess is that the noise that's being experienced on the output of the preamp could be from one of these tubes, either the reference, which is failing occasionally, or the ECL82, which could have a problem as well. These things are pretty old. Now, what I did was I took the output voltage, the B plus, and I put it on the scope, and I just left it there. I put the time scale at something like 20 seconds per division. And I did occasionally, and I had AC coupling, so I would see the thing at 0, and then occasionally I would see a spike. Very rarely, but I would see a spike. And my guess is that this particular one, maybe the other side is okay, maybe the other half of this, the other power supply is okay, but my guess is this particular supply has a problem. One of the tubes has a problem. Let me show you what the outputs are going to be. So I'm going to power it on now. We've got our little LED going on over there. And the voltage stays, we're measuring B plus regulated. So we're measuring pins 1 for ground and 3 for the regulated B plus, and as you can see it starts going up. And it gets 220.7.8 or so and it stops there. That's your regulated voltage. Now it will drift a little bit more, as we'll probably see, but that's where it's supposed to stop. And what we have here, I'm not sure you can see that, but the tube heaters are glowing, so the tubes are doing their job. So 220.8 is our B plus regulated, 221 over there. Let's have a look at the other one. So we've got that one. Let's look at that one there. 6.1 volts. That's that guy there. Yep, that guy there. 6.06 volts, which is fine. The next one we look at is, we look at the yellow, that one there. Right, yellow, 74.5. That's that one over there. And we know that this thing is 74.5 because, or 74.3 because there's a 6 volt difference between these two, and it's raised to a higher reference. So if we look at the bottom one, it'll be 6 volts below that, or should be 68.4. Brilliant. So we've got 6 volts between the white and the yellow, and reference to 71 or something like that. So this whole thing's doing its job just fine. And the B plus, where is it? There, 220.7, bloody stable. Very, very stable. Let's see if there's an AC component. Hell, that's noise. 3 millivolts of ripple, which probably isn't ripple because this thing is, it's not that accurate at that level. So this thing is a very, very stable power supply and very well regulated power supply, but very low current for a rather huge thing. If you've ever built your equipment yourself, you'll know just how much work goes into building this thing. They've built a separate box, all nicely done, beautifully done actually, brushed aluminium, black background there. A huge transformer, which can probably, my guess is this thing is probably 3-4 times the rating of what is needed for a 35 milliamp supply, plus the heater voltages. And then another chunk of metal there, that's the choke. 2 tubes, homemade PCB, really sort of DIY. I like this actually, it's quite funny. 2 linear regulators in a tube voltage regulator, but that's for the heaters, so yeah, that's fine. And there's 2 of these. 2 of these things for 1 preamp. Hey, if you like it, that's fine. I just find it a bit overkill. But I sure as hell enjoy working on them. And I hope you've learned something from this. I hope you found it interesting. In the next few days, I suppose, I'll be looking at the other supply, which is identical to this one. And then finally opening up the preamp itself. Maybe doing the reverse engineering on that. We'll see. So, yeah, let's just see what the regulated voltages now. And bloody hell, it's still 220.6.7. It's sticking there. That's pretty good. Right, bye for now.